Okay, dear students, welcome to the first module of the Excel statistical features. It is a custom that there might be times when you have a set of data and wish to compute some rather basic statistics, but you don't have the time to learn a new statistical package. So Excel is here to help you accomplish many of the basic and some of the more advanced statistical procedures. The aim of this course is to introduce you and the user to some of the basic statistical procedures available in Excel 2007. First of all, you should open the Excel book PDF file which is provided to you on the Libri first module, and also to open the stats exercise file which is also provided to you on the first module in the statistical data processing module. After opening the worksheet, which is named stats, here you have an introduction on how to open your file, which I suppose that you already know. You will have some introductory on what does the data represent. Okay, now let us have just an introductory of what we are going to investigate. The data you see are from a study that investigates computer anxiety in the middle school children. The data were collected from 49 graders from 3 different school systems. The first row of the data, from 49th graders from 3 different schools. The first row of the data set contains the label of the names, and here we have them introduced as follows. As you can see in the first, in column A, you have the ID of the student. So, from the first till the 40th student, you have indicated for each observation. So, if we are on A2, then B2 indicates that we are discussing about the first student who is a male and has experience 1. So after having the gender in second column, in the third column there is a column which provides you with information about the experience of the students on computers. So amount of previous computer experience. Then you have school, which is a school system. Then from C1, which is E2, up till C10, which is N2, you have responses from 210 item questionnaire that show computer and math anxiety respectively, continuing from O2 till X2 for the math questionnaire. Now, the test scores from computer course and mathematics course are given for this, for a given testing period. So you have in epsilon, so after finishing with X, you have in epsilon math score column, and in computer score column are provided in Z2. Now, 2 variables that are measures of computer and math anxiety based on questionnaire responses are CA and X, which is computer anxiety, and math anxiety, which are actually variables that we are going to create by our own during the course. Now, it is important for you to know that each row of data is a single subject. That is, each row of data tells us about an individual student. So, if we are concentrated here, we have for the student 1, we have the gender, the experience, school system, etc. So, the name of each variable appearing in the column label. So, this is the name of the variable. You could highlight them, or in this case they are not highlighted, but they provide the single variable name. Now, Excel is often used for data entry or manipulating data files for use in other statistical applications such as SPSS and SAS. Knowledge of particular limitations in other statistical application can help avoid some problems with data importing, such as those from Excel files. In SPSS, which we are going to continue after finishing with Excel, we are required to give each variable a name, and there are other restrictions about characters that can be used in names and length of the names. To avoid conflicts in SPSS, the variable names used should be either characters or less than start with a letter. The first column, data ID, is the ID of the student or the number of student, and a number that the researcher has assigned to each student. This can be different numbers assigned, for example, number of firms, number of individuals, etc. The second column is the gender of the student, and it is indicated with M and F corresponding to male and female. The third is the variable experience, which tells us roughly the number of years of previous computer experience. The number corresponds to the following time periods. 1 stands for 1 year or less. Okay. 2 stands for suburban school system, and 3 stands for city school system. Afterwards, the following 20 columns from C1 till C10 and from M1 to M10 are the responses to the questionnaires designed to test computer and math anxiety, with a 1 indicating highest anxiety and 5 indicating lowest anxiety. The next 2 columns, math score and computer score, are scores from tests given in a math score and computer score course, respectively for given time period. Now we start with computing computer anxiety and math anxiety. The 2 final columns for the data, such as math anxiety and computer anxiety, AA and AB, are not yet calculated. Both will contain summary data from the anxiety questionnaire given the test of the students, whose responses are recorded in columns E through X. The questionnaire were designed so that the responses close to 1 indicate higher anxiety about a given subject, and responses close to 5 indicate lower anxiety. By summing all the responses for, say, computer anxiety, we get a number that gives us a measure of total anxiety. Now let us illustrate different methods of data summary and description that we will be recording the values in columns AA and AB slightly differently. Let us start with calculating the value of computer anxiety for this data set. To set the location for this function, click in cell AA2. The result of the survey questions relating to computer anxiety are in columns E through N. Thus, to begin the sum function in editing group, so in home ribbon, in edited group, at the right of the ribbon, you find the sign of sum. If you select this sum, so click on the sum, Excel will automatically provide you with the sum from C2 till Z2. You need, so by press and drag, you need only to incorporate from C1 till C10, thus provide the values from E2 till N2. After having selected the correct file, to compute the formula, press enter. The value that appears is 23, which corresponds to the sum of the first students in actually this file. Now, if you are provided here with a triangle, which is a green triangle showing you that there is an alert of error message, go to the home button, and Excel options will provide you with some formulas, okay? And if you have formulas which omit cell in the region, click that untick and then press OK, and the triangle will disappear. This is the error option, error checking option, formulas which omit cell in region, okay? Now, let us compute with an E function the AB2 cell. So choose fx, which is an insert function, and select if. After selecting the if function in the select function list, click OK. You need to provide the logical test which the if function requires a user to first define the logical test. So in this case, the test will be whether or not the sum of given set of cells, which is from O2 till X2, is greater or equal to 30. So we would like to indicate that there are some students that have more than 30 and there are some of those that have less than 30 points. So just type sum and provide O2, be careful, not 0, 2, but O2 letter till X2, close the bracket, bigger or equal than 30. And you would like for true value to reply with 0 and for negative or false return to reply with 1. So, students that have more than 30 points responded in math anxiety will have a 0, and those that have less than 0 will be 1. Okay? Now, the computed formula should look at this. After having this window, click OK. Now, let us copy the computer anxiety formula and the math anxiety formula in the remaining cells for 40 students in the columns AA and AB. Now, let's see how can we paste the formula down to the column. So, click on cell AA2 and select the appropriate cells by pressing Ctrl, Shift and End at the same time. You will see highlighted up till the 40 students or cells row 41. Now, for after having selected, for filling the formula into the selected cells, go in the ribbon, which is just under the sum, and select the down option. Okay, so click down, and you will see that the cells will be filled by having 23, 29, 26, 24, 31, etc. And for the math anxiety, we'll have ones and zeros because we have provided an if function. Now save the file in the quick access toolbar because you would like these changes to be saved. We can now move on generating some descriptive statistic for our data. The descriptive statistic functions are descriptive, which organize, summarize and describe the data. Prior of performing any of more complex statistical procedures, let us see what are some of the characteristics which are measured by statistics, such as the mean, median and standard deviation. It is also important to have this information because the characteristics of data play a large part in determining which subsequent statistical procedures are appropriate. The insert function command in Excel feature that guides the user through various functions, so you can use these functions for organizing categories that include statistical, engineering, mathematical and financial functions. Once you become familiar with functions and how they are generated, you will learn how to enter functions directly. We'll use the insert function feature in the first exercise. Now let us locate our cursor in Y42. So go to Y42. Okay, and now let us use the again the function insert function and if function. So just average function, and then click OK, and Excel will automatically provide you with the Y till 41 number of columns included. And since you agree with this range of data, you click OK. And it will give you the result that 48 by 725 is displayed in cell Y42, which corresponds to the average of the values that you have in Y. So, using the insert function feature is only one way of generating statistics with Excel. Another method involves simply by typing the proper command for the desired statistical measure. Let us see how to find a univariate statistic by typing in the needed function. Now, calculating standard deviation. The standard deviation is a measure of the spread of values of a variable about its mean. The mean provides information about one characteristic of a variable. Using only the mean to describe a variable could be misleading. Why? Because, for example, if you have a city which has 10 inhabitants who have each $10,000 and their average, their sum is 100,000, their average would be 10,000. Again, you can find the same average if none of the inhabitants earns more than 0 and only one inhabitant earns 100. And 10 inhabitants, 100 divided by 10 will provide you again with 10,000 average. At the same time, there is standard deviation, which will give you different calculations, which is 0 for the standard deviation of the city, which has the mean of 10,000 and all the residents income of 10,000, and then will be standard deviation of 31.622 for the 9 residents having 0 income and 1 which have 100,000 income. Using statistical measures like the standard deviation would uncover such an even distribution and allow for more descriptive and accurate analysis to be made. Now we will use the same variable, math score, for this exercise. So select the epsilon cell, put your cursor in cell Y43 and give the sign equal to and start typing standard deviation, and you will see in the list, drop down list, so by double clicking it will provide you with the syntax and the numbers need to be calculated. Now press and drag from cells Y42 till Y2. And now you need the standard deviation for these values. Close the bracket, and for computing the standard deviation, press enter. The formula will provide you with 1608 or 0751241, okay, and this is displayed in cell Y3. What this means is that about 2/3 of the students have scores that fall within 16 points above or below the mean. The standard deviation function is appropriate for this case because our data are sampled from a larger population. Whenever the data are the entire population, one would use the command of standard deviation for population. Okay, this is just a note. Now let us go further and see using the data analysis tool. In addition to using insert function feature to perform statistical procedures, Excel also provides a prepackaged set of statistical procedure. The data analysis tools allows the users to select the statistical procedure and get results without having to type in a long, cumbersome formula. Now let us see what does the data analysis tool provide us. Using the descriptive statistics. Having more detailed information about our variables of interest, it is often necessary prior of doing any more complex or in-depth analysis. Additional information gives us a better sense of our data, as well as allowing us to choose the proper statistical procedure for the type of analysis we have in mind. Using the analysis toolpack, now to begin loading the analysis toolpack, click on the home bar and choose Excel options, click add-ins, and after choosing the analysis toolpack, which you have it inactive, click go and select the add-ins available analysis toolpack. Select after you click in the checkbox, click OK. Now it will be visible in the data tab, so go to data tab and there will be an access for analysis. Wait for some time if you need time processing for initializing. Now click the data tab and choose the data analysis which we have activated. After choosing the data analysis, a data analysis tool, data analysis dialog box will appear. And now let us select the descriptive statistics for us to provide some descriptive statistics for a given variable. To confirm this choice, click OK. And for input range, this box contains section in which we specify the input, the variable we wish to examine, the output, the types of statistical output to generate, and where we wish to have it displayed. Now, the top section of the window contains the input option. To indicate the range of the data we are interested in, we type its cell address in the input range field. So, if we would like to have statistics for the computer anxiety variable, which is located in column AA actually, let us type AA1 till AA41. Now, since we would like to organize our data in rows or columns by selecting the appropriate radio button. So we know that our data is arranged by columns, so it is good to have this radio button clicked. Since we have the names of our variables in the first row, then we need to indicate that labels in first row, okay? And since we would like to have the information in a new worksheet ply, then on the new worksheet ply field, type sum. So we will have a new worksheet that will provide us with the summary statistics. So click the summary statistics and your dialog box of descriptive statistics should look like this. So AA1 till AA41, columns, labels in first row, new worksheet with sum, and summary statistics. Be careful in your examination because also the naming of the worksheet is counted as point. Now for completing this procedure, press OK. Now let us increase the column width by double clicking between the column headings AA and BC, AB and BC, and click Save to save this file. As you can see, let us analyze a little bit the output. The Excel provides you with a detailed description of variables such as the mean of 29.92, the standard deviation, which is 3.33. We also have supplied with the minimum, which is 23, and the maximum, which is 40, which indicates that this variable has a minimum of 23 points and a maximum value of 40. We are also included with the statistics such as mode, sample variance, courtesy, skewness, etc. The number of observations, which is 40, such as count, which gives us the number of students in the sample. Now let's go back to state data and let us see how we can create a histogram and frequency distribution. Now we would like to have a histogram that will use the variable school for this exercise, and school indicates the type of school system the student attends. The value of 1 indicates a rural school system, 2 indicates a suburban school system, and 3 indicates an urban school system. Now, go to Study Data Worksheet tab and let us use AC1. Go to AC1 and type bin. Enter. In AC2, type 1 and press enter. Then type 2 and press enter, type 3 and press enter. So, we would like to have a bin variable which includes the values of 1, 2, 3, which correspond to 1 with the system schools that we discussed earlier. So, 1 indicates a rural school system, 2 indicates a suburban school system, and 3 indicates an urban school system. Now, after having the bin variable, let us create the histogram and frequencies. For generating a histogram, click again in Data Analysis group and select Data Analysis. In the line you have a histogram and click OK. After clicking OK, you are requested to set an input range, and since we are interested in providing input range for the variable school, and we know the variable school is located in the column D, so we provide with data of D1 till D41, and also the bin range which is located in AC1 till AC4, the variable that you generated. Okay, so type in bin range AC1 till AC4. Do we have labels? Yes, we have labels, so we tick the label checkbox, and we would like the new worksheet ply to be named Hist, which will provide us with a histogram. Sorry for the caps lock. So Hist, and we would like to have the cumulative percentages provided and a chart output. Be careful for ticking these two, because if you don't tick the chart output, you won't have a chart. Okay? After having a complete histogram box, which should look like this, then click OK. After clicking OK, in a new worksheet named Histogram, you will be provided with a table which has the bin, the frequency, and the histogram. Now let us modify the histogram. After having the histogram, you can see that you should probably resize the chart. Click on any blank area of the histogram, and with the lower right corner, handle down vertically. So just like this, you will be provided with a larger histogram. Okay? Now, changing the gap width, first we will remove the gap between the histograms columns by changing the gap width to 0. Go to start modifying the chart column, click one of the histogram columns like this, and the histogram columns will be selected. Go to Format Selection. In the Format tab, go to Format Selection. So Format tab, Format Selection, and you will see the Format Data Series dialog box, and you will see that the gap width is set to 150%. Since you would like to have it 0, you should press and drag the slide left to 0%. Okay, and now click Close. As you can see, the lines are actually now linked. Since we would like to be differentiated between the histograms, between the bars, in the shape outline, which is in the shape style group, choose a different color, which is a contrasting color such as red or black, whatever you would like. Now the columns are easily distinguishable. Next we will remove the more column. So the next task is removing the more column. Be careful, because the more column does not tell you much. You have just a more column which distracts you the histogram, such as here, and does not provide you with any information. So we must use a different method here, because if you just click delete, it will only delete the information and it will not remove the more bar from the histogram. So right click in the selected cells from A5 till C5 and choose delete. After deleting, say delete entire row and click OK. This will delete the more column from the table and also will remove the more bar from the histogram. Now the chart will change the title and axis of the labels. Let us start with changing chart labels. First of all, click the title and then double click the text to be highlighted. To change the histogram title, type number of students by school system. Okay? And the title changes. If you go to the x-axis and click on the bin label and then double click for highlighting the bin text, and we would like here to have school system type so that the graph is more, so just type here school system type. Okay, and now you know that for the school system type 1, 2 and 3 you have the number of students in each school system, and you have the frequency cumulative, which starts with 12 point something and finishes at 100. Okay, be careful that we might also want to have the labels named. Thus you can also put names in the table, and instead of 1 to stay rural, in 2 to have suburban, and for 3 to have city. Okay, now the names will be in the bars showed as rural, suburban and city. You can click save to save your worksheet, and you have a better histogram, which now shows you some information regarding the students who follow rural, suburban and city school system. Now let us create the second histogram. For creating the second histogram, we would like to consider the math score variable. It can take values from 0 to 100, and we would not want a histogram to have 100 different columns. Thus, we might, however, like to create a histogram for math score where each column held all of the values in a range of 10. In other words, the first column would account for all math score values that fell between 0 and 10, and the next column from 11 to 20 and so on. To begin construction of such a histogram, we must change to the Histogram 2 worksheet to our workbook, where the math score data and the set of proposed classes have been recorded. To access the Histogram 2 worksheet, go to the bottom of the sheet and change from Stat Data to Histogram 2 worksheet. Put your cursor in cell C1 and put the bin range or the name of the variable, such as bin. Then put in the cell C2 type 10. In cell C3 type 20 and press enter. Now to select the two numbers, press and drag from C2 till C3 and then fill the handle until you reach in C11 100. Okay? Now to select these cells, type in any other cell and let us generate the histogram. Go back to the data ribbon, data tab, and choose the data analysis and choose again histogram by pressing OK. You know that the input for the design input for the range of the variable math score is the input range from A1. You can click here and select from A1 till A41. Okay? Press enter. Then go for the bin range and select the bin range. Select C1 till C11 and press enter. Okay? Make sure that the labels is ticked, and for the output range, write your button, select in the output range. So we would not like to have a new worksheet since this is already named Histogram 2, and select cell D1, which indicates that somewhere in D1 will start the histogram. So if you have completed this dialog box, you need cumulative and chart selected. To continue, press OK. Now, let us see. Here we have the bin, the frequency, and the cumulative, and you have the histogram. For enlarging the histogram, press in any blank area of the histogram and with the lower right handle corner, select vertically and your histogram will be enlarged. This is very large. Make it smaller. Okay. And now we can see a histogram of from 10 till 100 data, and we can see that the math scores are more or less concentrated between 40 and 60. This is the histogram. Looking at the results in the table, we see that we have fairly evenly centered around pins 40, 50 and 60. Since you have learned how to modify the chart, now it's up to you if you would like to make some changes on this histogram by making it with a different title, such as the math score, student math score, then in bin to have just the math score, and then to remove the gap between the bars and also to remove the more column. Okay, so that will be up to you. Let us go to the next section, which is exploring multiple variables. So far, we have examined only in isolation variables from one another. This will not always be your task, because you might be sometimes required to see and define the relationship between two or more variables, as well as to determine the strength of this relationship. Thus we go and let us see how to have a pivot table. Pivot tables are one of the Excel tools which summarize two or more variables. In a simple two-variable pivot table, all of the values of one variable are compared to the corresponding values of the second variable. For example, the pivot table below shows the Democrats, Republicans and Independents cast their votes for candidates from three different parties. As we can see, for example, Democrats, which have independent votes, consist of 11.11, whereas Independents who have independent candidates consist of 30, etc. So these are some of the combination of pivot tables. Let us see, in this case, we are going to access the pivot table options and provide the pivot table for our data. So, for generating the pivot table, let us go to the Stat Data Worksheet. So, click on the Stat Data Worksheet tab and let us access pivot table option via the Insert tab. So, go to Insert tab, just make sure that you don't have selection, and choose Pivot Table in the Pivot Table group. So for creating a pivot table dialog box appears and requests a table range, which we would like to be for the data from C1 until D41. So as you can see, we would like to create a pivot table for the experience of the students in different school systems. Okay, so the table range would be C1 till D1. And let us use a new worksheet. So just click the new worksheet radio button, and to proceed, click OK. As you can see, a new worksheet appears with the experience and school variables which appear on the screen, and you see the pivot table fields like this. Now let us create the pivot table. Start with experience. For specifying experience as a column label, press and drag experience down to the column label area, and you will find it here, column label and experience here. Now we are ready to list school as a row label value. So for specifying school as a row label in the pivot table, press and drag school down to the row label area, and you will have school in the label area. For placing experience in the values area, press and drag experience in the values area. It will automatically Excel provide you with the sum of experience, but we are not interested in sum of experience, but we would like to have count, because we can easily calculate the percentages. For doing this, for modifying the sum of experience field, go to sum of experience and click on the arrow and select value field settings. After having opened the value field settings dialog box, choose count instead of sum, and in the field of show values as, you would like to have values as percentage, not normal but percentage of rows. After selecting the percentage of rows, click OK. Now we see the pivot table appear in this format. Let me close this. So this is the format of pivot table so that it has more meanings. Let us rename the column label. Just select B3 and type experience. Now select the row label and type type of school. Press enter. Now you have experience 1, 2, 3 and type of school, which we already know that are rural, suburban and city. You can also name the labels, and you can also correspondingly the column labels, for example less than 1, about 2 years and 3 years or more. Let us also rename the worksheet. Double click on sheet 4 and type pivot. It is important that you should do this on your exam so that I know that you have named it as a pivot. Now the interpretation of the results is that 46% of students in rural school have experienced less than 1 year. Almost 54% of students from suburban school have approximately 2 years of computer experience, and somewhere 57% of students from urban school have had 3 or more years computer experience. In grand total row, you have at the bottom of the table, this indicates 37.5% of all students have less than 1 year experience, 35% have had more, almost 2 years experience, and almost 88% have 3 or more years of experience. So this is actually the result that you can find according to the pivot table. Click Save on your worksheet for saving the file. Now let us generate a t-test. A t-test is an inferential statistic analysis used to decide whether two population means are the same or different. Although the theory of Ttest is rather involved, it is now within the scope of this workshop to discuss in depth how the t-test works. A brief explanation will help us understand how we can use Excel for performing a t-test. Now you have just a simple explanation of generating the t-test. Here you are provided with a normality of group A and group B, and the null hypothesis is that the two samples come from population with the same mean. So the alternative hypothesis is usually that the two samples come from population with different means. Now the t-test, we will calculate the probability of obtaining two sample values as far or farther apart that the observed values if the null hypothesis is true. Now, in the scope of this test is for us to provide a t-test. Now let's go back to the stat data worksheet and see what are the math score, and we will use the math anxiety for creating two groups for those students that have less than 0, or who have 0, which is more than 30 points, or who have 1, who have less than 30 points in the math anxiety. For doing that, so go to the home button and to begin the process of sorting, position your cursor in AB1, okay, which is the math anxiety variable. And now let us prepare ourselves for sorting the data. Use the A to Z sort and filter and sort A to Z. By doing so, the data will sort your variable by selecting only, leaving only zeros at the beginning and then 1 at the end of the variable math anxiety. This will help us for providing two groups, for students up till 29 who have only zeros, and for those from 30 till 41 who have ones. Okay? Now let us create the f-test for unequal variances. Go back to the Data tab and select the Data Analysis. And in Data Analysis, let us use the f-test for generating two samples for variances. Choose f-test, two samples for variances, and click OK to continue. As you know, the 29th row had also 0, thus for variable 1 type the range epsilon2, be careful, epsilon2, because we do not include the label, up till epsilon 29, because there were up till epsilon 29 the number of students who have 0, and then epsilon 30 up till epsilon 41 for the number of students who have actually the second group. Okay, now we don't type the rate, but we would like a new worksheet apply, and here type f-test because you would like to know that you have the f-test provided. After having a look at a dialog box for f-test to sample for variances like this, then you are ready to press OK. For running the f-test, press OK. Now double click between the column headings of A, B, B and C and D. Now deselect the cells and you will see the results like this. For interpreting the results, you can notice that in B5 and C5 you have the mean of the variances for two samples, and you have the variances in B5 and C5. After looking at the variances, the first impression is that 191 and 231 are respectively different. And the null hypothesis is true that the population variances are the same. What is the probability that we would find this much of difference in the sample variances? Now the answer to this question is the p-value, which is located in B9. So in B9 I will highlight it in let's say reddish. So it's 0.328. You should be careful because this is approximately 0.658 because it's one tail, and if provided for a two sample of variance for two tails will be multiplied by 2. Thus, we fail to reject the null hypothesis in this case and conclude that the mass score variances of the two anxiety populations of 0 and 1 are not statistically significantly different. Hence, we will run our t-test assuming equal variances. Okay, so this test provides us just an indication of what kind of t-test we should provide. So a t-test assuming equal variances. Let us go back to the stat data worksheet and let us provide the t-test by going to data analysis, and in the list we look for the t-test to sample assuming equal variances. So t-test assuming equal variances. Click OK, and now give the range of epsilon 2 up till epsilon 29, and then for the variable 2 type epsilon 30 until epsilon 41. Since you specify these two variables, then we would like to have it in a new worksheet, which is a t-test. Be careful because in exam you should name this, and then if you have a view like this, then you can press OK. Again, between A, B, B, C and C, D, deselect the cells, and now your t-test worksheet looks like this. Okay? As you can see, we are provided with the variances which were the same as in previous, but now in B13 you can see that the p-value is just around 0.002, which is less than 0.05. So we reject the null hypothesis in this case and conclude that there is a statistically significant difference between the two populations for the values of math score. In other words, the students with low math anxiety have an average math test score that is significantly different from the average math test score of students with high math anxiety. Now we need to resort the data, go to the stat data worksheet, click cell AB1, okay, and to prepare to sort the data on the data bar in the sort and filter group, click AZZA, the sort dialog box opens. Now in the sort by field choose ID because we would like to have them from 1 to 10 as they were originally. After selecting ID you have the sort dialog box that looks like this. Now click OK. As you can see, the file is resorted and click Save. Now let's go and let's perform or find correlations. Another means of testing if any relationship exists between several variables is determining whether they are correlated with one another. Correlation measures whether the magnitude of one variable predicts the magnitude of another variable. An example of negative correlation would be temperature and heating oil consumption. As the temperature outside decreases, consumption of heating oil increases. Let us find the correlation. Go and we would like to find the correlation between math score, computer anxiety and math anxiety. For performing this, go to the data analysis group, click data analysis, and to begin click correlation. Choose correlation and press OK. In the input range, since our variables are positioned from epsilon1 till AB41, type in the input range epsilon1 till AB41. Then you would like to have selected the labels in the first row checkbox, and also for generating the correlation, click in the new worksheet apply core. After having such a drop box of correlation, press OK. Again, you can just enlarge the cells and press any other cell to select the table, and now you can see that the math score and math score, so each variable with itself is 1, and these values here provide you with the correlation between two variables. For example, the correlation between computer anxiety and math score is 0.07, which is very low, which indicates that there is no correlation and this variable does not much explain the other. While in the other hand, for the correlation between computer score and computer anxiety, you see higher correlation, which is 0.657. Okay, so by interpreting these results, we see that there is also a very small relationship between score on math test and score on computer test. Okay, so math test and computer test is somewhere 0.14, whereas the moderate and positive coefficient of 0.65 says that there is a correlation between scores in the test in computer classes and the level of computer anxiety with a positive coefficient. Now we are, let's say, more prepared for performing a simple linear regression. Now we might suspect that two or more variables are related and wish to test this relation using a statistical technique somewhat more powerful than a simple correlation. We want to know with some precision how changes in one variable might be reflected in changes in another variable. For doing so, the proportionate change estimated by the regression procedure is called the coefficient. Thus, we can describe a model for testing the computer anxiety A plus B, which are coefficients of computer score. Now let us return to the main worksheet, which is the Stat Data worksheet, and go to the Data tab and select Data Analysis. And now we would like to perform a regression. Press OK and the regression will appear. For continuing, we would like to see, to enter the values that we would like to have as epsilon variable, which is epsilon range, and in this case press AA1 till A41, and for the X range we would like to have the computer score variable, which is Z1 till Z41. Okay, so epsilon for us represents the the dependent variable, which is AA1 till A41, which is computer anxiety, and we would like to know how does the computer score, which is the X variable and presents the independent variable, have an impact on the dependent variable, which is computer anxiety. Okay, since we have labels in the first row, you should tick the label, and also we would like to name this new worksheet as reg, okay, which will provide us with a regression. The completed regression dialog box should look like this. After having this view, then for completing the procedure, press OK. Sorry, must be a single row or column. Okay, so we need A1 up till AA41, which is the input epsilon, and sorry, I have probably set only one A, and now you have the regression results. After having the regression results, you can see two parts of this table. So in interpreting the results, you can notice that there is the regression statistics and also the coefficients. Okay, so in the first section, the regression statistics give you an overview of how well our model is performed. It is R squared, a statistic that is very important, and in this case it tells us that the 43% of the variation in student computer anxiety can be accounted for by variation in how well they did in computer test. The third section gives you the intercept and the computer score, which is actually the part which are in which we are interested. In particular, the coefficient of the computer score, which is 0.13, indicates that for each additional point for a student's score on computer test, there will be an increase in their computer anxiety score of 0.13. Remember that the higher the computer anxiety value, the more comfortable the student feels with computers. So this makes sense that by increasing the computer score, the students that tend to do well in tests in their computer class also tend to have lower level of anxiety about computers. The intercept of 23 indicates the level of computer anxiety a student would have if their score on computer test was 0. Okay, now we can also generate or create a scatter chart, which is a better view of the actually regression result. Now let us go back to Stat Data worksheet and let us perform a chart. To select the first data set of computer score, click on the column selection area as it is set here Z. So select the column of computer score. Now press and hold Shift and select the AA column. After having selected Z and AA, go to Insert tab and in the area of chart, in the chart group, click Scatter. After selecting Scatter, select the view, the first scatter view, and creating a title and axis. After having a chart like this, it is better to have a better title than CANX, which in this case is correlation computer score versus computer anxiety. Okay, rename the title. Then we would also like to provide the label for the X, which is independent variable, which is shown here, and we know that the independent variable is computer score. So go to the layout tab and choose the axis titles and then primary horizontal axis, and instead being selected as none, choose title below axis. And now for the title below axis, you can name this by typing comp score. Press enter. After naming comp score, you also would like to have for the deep independent variable name. So go again to axis title and choose primary vertical rotated title. Double click in the title and type Tsana X, which is computer anxiety, and then press enter. Now the axes are now named properly. We would also not like to have a legend like this, which does not show us much. So go to the legend and press none. So you would like not to have legend. Now to switch to the design tab on the ribbon, go to design, and we would like to move this chart to new worksheet. So just press new worksheet radio button and type scatter plot. Okay, after having it in another worksheet, now let us format the chart. To switch to the layout tab of the ribbon, press layout. After having the layout, let us adjust the x-axis. Since you have no dots before 20 and in both variables, independent and dependent, we would like to remove this space. So just go axis and select primary horizontal axis, more primary horizontal axis options, and in the first of minimum, we would like to have the minimum of 20. After typing 20, press close, and as you can see, the values will be moved and the axis starts from 20. Let us do the same thing for the primary vertical axis by choosing more primary vertical axis in the fixed, type 20 and click close, and as you can see, now the dots are spread just from the very beginning and up. Now we would also like to have the regression line, which needs to be added by clicking in any data point. So click in any data point, right click and choose add data. Sorry, not add data labels, because it will add data, but add trend line. After choosing trend line, the trend line will appear for linear automatically, and you would like to have the trend line linear, but also to display the equation in the chart so that you can see the regression results, and also to display the R-square in the chart that you already know that it is 43% for the variability in the dependent variable of CANX. Now to return to the chart, press close. You can also press and drag this dialog, this box which appears with the data in a field in which you don't have any actually line beyond, so that you can read clearly what does this data contain. So please click save so that you can save the data. And how can you interpret the results? The results, both the simple regression analysis and the scatter plot trend line, yield the same equation. When we put the coefficients into the model, we can see that by setting for epsilon CANX and for X computer score, you do not need to do this, but I'm doing this just for having better interpretation. You can see that computer score by an increase in 1 point the computer score, the students will increase their confidence in computers for 0.133. If you put a value here, then if computer score is 70 points, let's say, then the computer anxiety will be 32.5. If you put a value of 30 in the computer score, then the computer anxiety will be 27.18. The second student with a lower test score has higher anxiety about computers than the student who had higher test score. Okay? So this is it. This is the module for Excel. Now you need to, after having completed this actually work file, you can save it with stats and your ID and submit it to the Dropbox. I also want to inform you that the exam in Excel will be very similar to this file, so you need to fill in your exam and then put it in the Dropbox after, as I have requested. Now for quitting Excel, go to the home button and press exit Excel once you have saved it. Okay, just yes here and close the Excel. Thank you for your attention, and I would appreciate a lot if I received a completed file such as this one presented in this module. Bye.